Yeah. So this talk is going to be about AI agents and internals of AI agents. So I think 2025 is going to be the year of AI agents. A lot of startups would like to add AI agents to their business in some way or the other. And I feel if it is going to be that important, we should dig one or two levels deeper and learn how how an agent actually works. So that is going to be the motto of this talk. I'm Sai Yashwanth. I am an AI research engineer. I work at an early stage startup. I work at VOC. I'm also an author under Manning Publications. Me and the founder of VOC, we are writing a book on multi-agent systems. So whatever I do, it's all about AI agents. I'm also a co-founder. I founded an agency called turilabs with my friend, where we give AI services to our clients. Apart from that, I worked in Composio the previous summer. Composio is like an AI agent toolset company. It's not just a toolset company; they do more than that. But yeah, most of the AI agent stuff I learned is from that startup. I'm also a student. I'm in final year. I study at Pest University. I'm from Bangalore, and these are my socials. You can check out. You can follow me on Twitter, where I post threads and like a lot of insightful stuff. So yeah, let's start the talk. So the agenda for today is first I'll tell you what an AI agent is. I'll get you familiar with AI agents and agentic workflow or whatever, all of those stuff. After that, we'll see how you can turn an LLM into an agent. And then we'll discuss about tool calling, planning. These two are like the most important bricks for AI agents. Then there's this method called React framework, not the web framework, but this is a methodology to convert your LLM into an agent, React basically means reasoning and action. We'll look more into it. After that, I'll show you some prompts on how some prompt templates on how you can convert your LLM. And then this one last topic which I thought of adding, which is program aided language model. We'll look into it. So yeah, what are AI agents? So I took this screenshot from my personal blog where I talked about what AI agents were. So to describe you what an AI agent is, like you're a 5 year old. So let's just assume that an AI agent is like a human. We humans we have our ears and we have our mouth. Ears for input, mouth for output. If you take it like that. So and we also have a brain. So an AI agent is similar. It has an input. It has a brain, which is basically an LLM. It has an output. So you give something, it gives you output. Like LLM works like that. You give it a text, it gives you a text output. Now the fun begins when you give them tools, AI agents. So these entities, you give another entity called tools to them. This is where the whole thing changes. So we humans, we have arms and legs, right? We can walk, we can run, we can play football, or we can type, we can code. All of this we are doing using our limbs, arms and legs. So similarly for AI agent, it's tools. That's what I like to relate like that. Tools which can be used by these entities called agents to perform some sort of action, like sending a message in like Twitter or like WhatsApp or like LinkedIn or like searching the internet. These are the actions which these LLMs can do. These agents can do using these tools. AI agents without the tools are nothing. This company where I worked at, the startup during the summer was called Composio, which is basically a toolset company which provides like a lot of tools, a lot of like hundreds of tools for like different applications. And with these tools, your agents are useful. Without them, it's just a plain chatbot. And the main goal of agents is to make them autonomous, make them completely on their own with very little human in the feedback loop. So if that makes sense. So yeah, so agents, you know what an agent is. So how do you employ an agent in your business? So there's this thing called agentic workflow. This pre-agentic workflow, which is what people were doing before these agents came. So like maybe in 2022, even 2023. This is the year where we saw a lot of agentic workflows in business. So before these agents came, we had something called ETL pipeline. ETL basically means extract, transform, and load. So I wrote a thread, I think like around 2 weeks ago, where I discussed what ETL is and what AI agents are. Agentic versus ETL. ETL is where you know what the flow of your code will be, the business logic, how it will go, what you will give, what the input you're giving, and what the output which you're getting. So ETL is basically that extract, which is basically input, transform, where you perform some transformations, load, which is output. So you put something, you get some transformed output. And a pipeline, a structured flow is what people used to do before. But now things have changed. And I think things will change a lot in the coming year. I think 2025 is going to be huge for AI agents, especially AI agents in non-tech stuff like marketing, sales, and stuff like that. So compared to the previous pre-agentic era where we had ETL pipelines, we have agentic here. So they are dynamic. So yeah, the decisions are taken by the LLM. So humans just give a laid back structure. The agents are to decide. They decide what they want to do. Either they want to search internet, they want to search the database or whatever. They are adaptive, and this is very important. So they learn from the mistakes and they change themselves. This is what makes agents better. But the problem is agents, there's a error margin with when you have agents in your business, because agents can fail, especially with the LLMs which we have right now. Agents are not going to work that good. I myself have put few agents in production, and I've seen them fail like very bad. And so I think it's like around 85 to 90% times they work. So you have like 10 to 15% of error margin. It's not the prompts, or it's not the structure, the code you write. Agents are good, but the LLMs are not up to it. So, like the things which we have. So, that is something we have to keep in mind. So, yeah, some agentic startups. I've seen this startup is backed by YC. It's called Origami Agent, where they have LLM agents, basically AI agents, 24 by 7 online. They deploy these agents online, and these agents search the internet, social media, company pages, etc., and they find leads for you. So this is like a startup which like I think started like 2 months ago. It got they what they're doing is very futuristic, and like what something I like you will see a lot more coming in the next year. And one another startup is my own startup where I work at, Vuvosi, where we build like a co-pilot for investors and startup founders. We use a lot of we have like a lot of AI agents which work and then they give you output, but it's not as dynamic as like an actual agentic workflow because we don't want errors. That is the main thing. So yeah, now that you know what an agent is and how important they are, like what could be the future with them in like 2025, let's see how we can convert an LLM into an agent. So LLMs, if you see, they are basically an ML transformer based ML model, which which takes a text as an input and they give a text as an output. So I think that's how we interact with ChatGPT. What they do is they take the user's input and they do is they give the next word, they predict the next word from the user's input, and they do it recursively. So you have a text being generated, not just one word, but like a complete. That's how ChatGPT or like whatever GPT-4, 3, they work, transformer-based architecture. So how will you convert your ML model, which generates text, into an entity which can take actions, which can send messages on LinkedIn, WhatsApp, or like search internet, do this, send emails, read emails, reply email. How will you do that from an ML model which is designed to generate text? So there are two ways of doing it. One is you give two weapons, two powerful weapons to your LLM. One is the ability to plan. Another one is the ability to take actions. So there are two concepts which are very important: tool calling and reasoning. Um, So I'll go ahead with tool calling. I think the order was reasoning and then action, but it's fine, doesn't matter. So tool calling. So I wrote a thread on it as well, like 3 days ago. So so consider this: you have a situation, and you have like four options. You give the situation and these four options to your LLM, and these four options are the key to solve the situation, or at least to move ahead with the situation. Any one of these four options. So your LLMs are good that they can tell you which option is actually the one we should take. So this is like the basic idea of tool calling. You give your LLM some tools. So those options are basically Python functions. So you give some Python functions here. Use curly braces tools and system prompt. System prompt is basically like setting up a context. So you can give like maybe let's say you give a tool to check the weather, you give a tool to search the internet, you give a tool to send message on WhatsApp. These three are the tools you gave LLM, and then now you ask a question: what is the weather in Paris like? what is the weather in Bangalore like. So you get an output from LLM, which is not a general normal text. It is a JSON structured output. So your LLM is telling you that. So for the question which you have asked me, this is probably the tool you should use. Apart from that, some other data like parameters. So like your Python functions have parameters, right? So it just tells us. So if you go to the previous slide, when a user prompts an LLM with a query, the LLM doesn't execute the function. It tells us that this is the function you should use, and this is the function you should use, and these are the parameters you should pass. So it gives us a structured output, a JSON, which with the function name and parameters. So this is how tool calling works. So your LLM tells you that this is the tool which you need to run. So after this we have this function called get current weather with the set of parameters. So we have this Python method called eval, which can run anything inside. If you pass it, it can run it as a Python statement. So if you run that particular function, you will get some output. So this is the current weather that you give to your LLM. Then your LLM will give you an answer. So from running that tool, I got this particular output. So that's how that's the basic idea of tool calling. There's a lot of abstractions which frameworks like True AI use, but this is like the watered down version of what actually happens under the hood. So tools. So I think I explained tools. I gave an analogy like an option, right? 4 options. So tools are basically your Python functions. They are like API calls or whatever. You give them some input to the function, it gives you some sort of output and does some action, maybe like search the internet or send message. So you have your Python function with some docstring. The docstring contains what the function is about and then like what the argument it takes and what it returns. That's it. Yeah. So you pass a collection of doc strings to your LLM as the system prompt. System prompt basically sets up like a context to the LLM. So that is there, and that's how tool calling works. That is like the basic overview of how tool calling works. Now comes reasoning. So reasoning is, I think, a correct word for reasoning would be planning. So your LLM has to plan before doing anything, or else they will fail. Like, and there are papers which compared with only tool calling versus planning and tool calling, and they found out that planning is a good thing precursor for tool calling. So there are two ways of doing reasoning. This is not as difficult as your tool calling because reasoning is just sending the prompt. You just set the prompt. You tell the LLM to do it like this. That's it. So there are two ways of doing it. Chain of thought, tree of thought. I never use tree of thought, but basically, whenever you give it a situation, it assesses the situation, gives multiple reasoning paths, and I never really used it. So a lot of people use it, this chain of thought, which is like uh, the intermediate steps are thoughts, and this chain forms, and hence the name. So a linear reasoning process. So if you look, this I have taken from the paper, chain of thought paper. If you give it a question with some sort of mathematical reasoning or whatever, you give a one shot example and a prompt. The answer is not correct, but if you see the chain of thought prompting, where the one shot example, the answer is a chain of series of steps, and then the final answer is found out from these steps. And if you give the same question, it gives you the correct answer. This is taken from the official paper. What we basically do is we just ask the LLM to think like a human and do step by step reasoning, and then give the final answer. So if those two made sense to you, those two things, two weapons you give your LLM, tool calling and planning. If those two make sense for you, then that's it. You have built an agent. Theoretically, you have built an agent from an LLM, from an LLM call. So your LLM has the ability to think and it has the ability to take action. So this forms the basis of the React approach. And this is what a lot of frameworks like CrewAI or AutoGen use under the hood. So if you look at this framework, CrewAI, if you look at the output, if you like once in a while, if you run the agent, a single agent, and you see the output, how it looks like, it would be something like this. So you have something like thought. So like you ask a query. So based on that, the thought would be, so I have to do this. Then an action. Action is basically related to tool call. So based on the thought, I have to take this action. And then based on the action, whatever output I've got, this is the observation. And this loop, action, thought, action, observation, this loop continues for as long as it wants. And when the final thought is that, okay, now I'm confident to give a final answer, then you break out of this loop and you give the final answer. This is how Crew AI works. If you looked at the previous slides, Crew AI uses a chain of thought. It uses tool calling, and that's how it runs its agents. And that simple thing can like make a lot of changes. So this is also taken from a paper. There's this data set called Hotspot where it has like a lot of question and answers. So if you look closely, you will see that normal question, if you ask, it fails. Chain of thought also fails. Only action. So you give a Python function to it and say that this is like a search function. You can get answer. Still fails. Reasoning, that is planning plus action, both of them combined, it doesn't fail. It gives you the correct option. So this is like actually like a very good thing people use to build agents. And actually, the same paper, if you there's another study which did it where even reasoning and action failed. So they had to bring a human in the loop to assist sometimes, and then it worked. So the goal right now, we can't have 100% React. That's why I said there's a error margin. Our goal as humanity, or like all the researchers, their main goal is to reach to a state where LLM is able to do everything without a single human interaction, without a single human in the loop. So this, I don't really know when it happens. Although this paper was old, I think probably 2023. So now we have GPT-4, GPT-O1, which can reason on its own. That plus React on top of it, I think they can be good. But I still assume there would be some sort of error margin. So it would take some time, I think, and that is what I feel is AGI. So when we have like zero error margin and your agents are able to do everything which you throw at them, probably they are generally intelligent and we have AGI. So here are a few of the prompts which I have. So this prompt is taken from one of my projects where I had to make an LLM solve a math problem using chain of thought and without using chain of thought, and compare the results for like different LLM providers, GPT-4o, Claude, and Mistral. So the prompt was same for all the agents. All the LLMs. What the prompt, if you look at chain of thought prompt, you basically say that whenever you're given a question or a problem, carefully break it down into smaller and smaller modules, think through them step by step, and then give the final answer. That's the basic bare bones structure of a chain of thought prompt. So this, I think, is the same which I used, and this is taken from the official LangChain prompt hub, where the React prompt this is. This is what LangChain uses for their agents as well, React agents. So this is the React prompt. I think Crui also uses the same prompt. They might have a more sophisticated, more researched prompt, but the idea is similar. You give the LLM the set of tools which you have. You also give it a one-shot example where you give a format and ask it to only think in that format. Question, thought, action, observation, final answer. This thought, action, observation loop goes on and on till the thought is that I know the final answer. If you look into the prompt, you'll know. Like if you'll understand. So once the thought is that it is confident about giving a final answer, it should give the final answer, and that should end the loop. That's how React works. You give it a question, and then first it assesses the question, thinks about the question, then based on this thought, it takes an action. Based on the output you get from this action, you have an observation, and the thought again takes this observation and sees if this is sufficient to do what the user has asked me. If not, run the loop again. Do it till the thought is actually sufficient to answer the question which the user has asked. This is how it works. This is like the whole, how Crew AI or like AutoGen they work. The whole thing. They have chain of thought and tool calling. So I have this one more, concept called program aided language model, which is something researchers came up with where it's similar to chain of thought, but instead of the intermediate steps being a thought, it is a Python code. So I think if you look into this diagram, I've taken this from Chronicles LLM's notebook. I'll leave the link in the last slide. But basically, each intermediate step is a Python code. So if you look into the example, if you look into the image, you have a one-shot example, and then you have a question and answer, and a question. So the question is some mathematical problem. The answer is some Python code with comments, and this is like a one-shot example. And then you ask again another math question. The output which the LLM gives is again Python code and with some comments. So those comments are like intermediate thoughts, and you also have code in there. So this way, and when you execute this, you get the answer. That is what the LLM returns. So this way, you're turning your LLM uh, to solve complex mathematical. This is a very simple problem, but yeah, LLM fail to like even solve this sometimes. Obviously, the new oven model has this inbuilt, so that is there. But you're converting your LLM into a Python coder, which can code the problem, which can convert the problem into code, and then give you the answer. So this would have like zero error margin, but yeah, like this is there's still research to be done. I have never really used this particular method in like building agents. So yeah, this is taken from their paper, from the program-aided language paper. What we do here is you have chain of thought, you have program, and they compared the same question but with the different methods. The answer from chain of thought did not work, but the answer with program aided it worked. You had the output had Python code, so when you run it, you get the correct answer. So that's how this works. So yeah, I have all the links here. I think if you guys have any questions, you can ask me. Rashmita, do we have any questions?
We don't have any questions at the moment, Sai, but folks, please, if you have any question, please feel free to drop all your questions in the comment section, and Sai is here to answer them. In case if you don't have any questions at the moment, then I will share his social handle also in the comment section for you all to reach out to him. Okay, I think we don't have any question at the moment. Yes, Fahim, this session is on YouTube. So you will find this session right after once we are done. It's available at the Reactor YouTube channel. Okay, I think, okay, so we have one question from Siddharth. Let me bring that up on the screen, Sai.
I think Crua is better because they're funded and like they have like I think I don't know, I think 20 million fund. No, I'm not sure, but they're funded and like a lot of the community is good. Langchain is also better, but Crua has like a slight edge, is what I assume.
Okay, next question.
The steps it's there in the slide. So basically, there in between I had a slide where I talked about how your LLM can be converted into an agent using chain of thought and action tool call. So if you want, like maybe you can text me. I can help you. Maybe send a big message with it explains.
Okay, then we have another question.
Yeah, Llama is a LLM model provider. From what I know, they have like multiple models like Llama 3.1, 3.2. For experimentations, I use Llama like because I have a PC with a good GPU, so I run these LLM models to test out. But when in production, it's good to use GPT or Claude is what I would tell. Depends on the budget as well. Yeah, depends on the application. Yeah,
Okay, and we have another question.
it doesn't come in reverse. So basically, your LLM, your agent, LLM is part of your agent. It's like brain. So that example which I gave, your agent has LLM as its brain, as its processing component. So it gives out what to do. Or like for us, our brain is a similar comparison. Your LLM, I mean your agent, the brain is LLM.
Okay, thank you. Another question.
There is there are some data sets. Even I'm not that good with benchmarks, but there are some data sets that you can use. I will like maybe give you some link later. I don't remember the website name, but that data set is good for benchmark.
Okay. Next question from Deepak.
I think O1 is a LLM. It is like an LLM inference which GPT gives, OpenAI gives you. Langflow, CrewAI, Autogen, these are frameworks which use LLMs to they put some abstractions on top of them to give you some sort of actions or like some sort of out of the box, like what do you say, task or whatever. So if you ask me in terms of cost, Autogen is good, CrewAI is good. O1 is not good for production level. It'll cost a lot. So CrewAI O1 is basically your GPT-4o with reasoning and action steps. So I don't think there's any need to do that.
Okay. So I think, Sai, that's all for the questions that we had. Thank you so much, Sai, for hosting this session, and thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming sessions. Also, we would appreciate your feedback on today's session as it will help us to curate future session. Please scan the QR code and do share your feedback. And today's event ID is 24121. Feel free to use the Learn module link. This will give you access to additional resources to take your learning further. Thank you all once again and enjoy the rest of your day.